Welcome to Brain Vision.
In this problem, a ball is thrown onto a rough floor at an angle theta and rebounds at an angle phi. If we know the coefficient of kinetic friction between the ball and the surface, we are to determine the coefficient of restitution. Firstly, let's look at vertical components of the coefficient of restitution, E. And E is equal to 0 minus V2 sine phi all over V1 sine theta minus 0. So during the impact with the ground does not move, and so the velocity of the ground is 0 before and after. However, the ball has y components of its motion. And so from here, we can see that the coefficient of restitution is V2 sine phi over V1 sine theta. So if we can eliminate V2 and V1, we have found the coefficient of restitution in terms of only the angles phi and theta. Now we'll take horizontal components of motion, and we'll use the principle of impulse and momentum. So along the x direction, the momentum initially, m vx1 plus the sum of all the horizontal impulses, which is the integral of f in the x direction dt, and this must equal to the momentum of the ball after the impact, m vx2. So if we set up our equation, this is m v1 cosine of theta minus fx delta t, and this must equal to m v2 times the cosine of phi. So everything on the left-hand side of the equation happens before the impact, and the right-hand side is the momentum with which the ball rebounds. So we can rearrange this equation and find the x component of this force which causes the impulse. And this is m v1 cosine theta minus m v2 cosine of phi all over delta t. Delta t is the total time of the impact. So we'll call our first equation for the coefficient of restitution equation 1, and this x component of the force equation 2. Now we need to find the y component of this force. We'll use the same method, but look at the vertical components of the motion. So again, we'll use the principle of impulse and momentum. So m vy1 plus the integral over time of the y impulses, fy dt, must equal to the final momentum in the y direction, m vy2, the momentum of the ball along the y-axis. So this is m v1 sine theta minus this impulse fy times delta t, and this is equal to minus m v2 times the sine of phi. So again, if we rearrange this equation, we can find the y component of this force that acts between the ball and the ground to be m v1 sine theta plus m v2 sine phi all over the time of impact delta t. And we'll call this equation number 3. So we've got the y component of this force. Now, since we know that Fx is equal to mu times Fy, this is given, then we can use equations 2 and 3 and write the expressions of the force as follows. So m v1 times the cosine of theta minus m v2 times the cosine of phi all over delta t must equal to mu times Fy. So that's mu, the coefficient of kinetic friction, into m v1 sine theta plus m v2 sine phi, and this again is all divided by the impact time delta t. And so from here we can create a ratio. If we divide both sides by v1, we get v2 over v1 to be the cosine of theta minus mu sine theta. So we divide both sides by v1 and then rearrange all over mu sine phi plus cos phi. And so now we have an expression for v2 over v1 in terms of our angles. And we can go back to equation 1 and find our coefficient of restitution, E, which is now sine phi over sine theta into cos theta minus mu sine theta all over mu sine phi plus cos phi.